Hello everyone, this is Dr. Sayar from DENTABEST, your best online mentor for the preparation of IMBD, ADAT and EFK exam. Please like and subscribe to my channel on YouTube and follow me on Facebook, Insta, LinkedIn, TikTok. Please do visit my website at dentabest.com where I'm offering different personalized and smart study programs to help all my hardworking students at a very affordable cost. So today, we are going to do a topic of orthodontics, that's orthodontic tooth movement. So let us try to understand what are the two scenarios that can develop while you're doing the orthodontic tooth movement using heavy forces or using the light forces. So with the light forces, students, the movement is going to be more physiological. With the heavy forces, the movement is not going to be any faster. The reason is that with the heavy forces, you have a formation of what is called as a hyalinized zone. And hyalinized zone is actually the necrospedial. So with the heavy forces, as soon as you apply the forces, there is something, bone bending will start. Piezoelectric signal, which is like a spark with a quick decay rate, it will be produced. Fluid is expressed and the tooth moves immediately in the socket and the patient is going to experience the pain because the blood vessels get occluded. Now, the blood flow is cut off with the heavy forces and the occlusion of the blood vessels and the formation of hyalinized zone. So, the zone has to heal first and then the second phase of tooth movement will start. So, with the heavy forces, we are going to have a lagged phase in between the initial phase and the secondary phase of tooth movement. So, overall, with the heavy forces, the tooth movement is going to be delayed rather than being faster. Also, with the heavy forces, we have what is called as undermining resorption. Undermining resorption is where osteoclastic activity is higher than the osteoblastic activity. Now, when we see the light forces, with light forces, you have more physiological tooth movement. So, tooth is definitely started moving when you apply the force, but it will be slow. It's more physiological movement. The blood vessels, they will get distorted rather than getting occluded. There is no pain that is felt initially. The blood flow and the oxygen levels are going to get altered and the inflammatory mediators like prostaglandins, PGE levels, Rankine levels, they are going to increase. Along with that, you have some neurotransmitters, some hormones like calcitonin, substance P that are being produced. The CAMP levels, which is a secondary messenger, it's going to increase, the cell get differentiated. And with the light forces, you have what is called as the frontal resorption. Frontal resorption is when the osteoblastic and the osteoclastic activity, they are balancing each other. Okay, now let us try to understand what is center of resistance and what is center of rotation. So, center of resistance is on the long axis of the tooth. It is situated between 1/3 and 1/2 of the root length apical to the alveolar crest. So, you can see this point here. So, this is the root we have. It's around this point where the center of resistance is located in a tooth with a healthy perio. But as the tooth is periodontally compromised, the center of resistance is going to move more apically. The center of resistance is an imaginary point around which the entire mass of the tooth is being concentrated. Now, when we talk about the next one, that is your center of. Now, for a multi-rooted tooth with a healthy perio, the center of resistance is probably between the root 1 to 2 mm apical to the furcation point, if you can see here. So, center of rotation is a point at which rotation actually occurs when an object is being moved. So, depending upon the force of the system applied, the position of the center rotation, it may vary. For example, in cases of controlled tipping, the center of rotation will be at the root apex, while in case of perfect translation, it will be at infinity. So, before we proceed with that, firstly, we should try to understand what is tipping and what is translation. So, tipping is a movement when the crown and the root apex, they move in two opposite directions. That's a tipping. While translation is when the crown and the root, they both move in the same direction to the same extent. Now, let us try to understand what is movement of the force. So, tendency of a force to produce rotation or tipping of a tooth is the moment. So, moment is determined by multiplying the magnitude of the force F by the perpendicular distance from the center of resistance to the line of action. So we can say M equals to F times D. That means more is the D, more is the distance, moment is going to increase. Now let us try to understand the difference between controlled tipping and the uncontrolled tipping. So if you can look at here, this is the crown, this is the root, and controlled tipping occurs when a tooth tips about its center of rotation at its apex. You can see here, center of rotation is at the apex in the tipping movement, and then you can see the tooth is tipping in this direction. Right? So this is going to be a controlled tipping. But what is uncontrolled tipping? It occurs when the center of rotation is between the center of resistance and the apex of the tooth. So if you can see here, so this is the center of rotation here, and let's say your center of resistance is somewhere here, half to 1/3 the distance from the root apex, and this is the tip. So uncontrolled tipping can occur with the use of elastomeric power chains in order to close. So I briefly already told you about the translation. So let us talk more about the translation. So translation is when all points of the tooth, they move equally and in the same direction, right? So if you can look at the picture here, so this is the tooth original position, and see, once it has translated, both the crown and root, they have moved to the same distance in the same direction, right? So this becomes the translation. So here the line of action of applied force is passing through the center of resistance. So if you have a center of resistance and the force is applied through the center of resistance, that's when the translation is happening. That means the root and the crown, the root apex and the crown, they're moving in the same direction to the same distance. So to counteract the tendency for tipping, a couple can be applied intentionally to provide a movement of equal magnitude in the opposite direction. When a moment to force ratio is 10:1 is applied to the bracket, the equivalent force system at the center of resistance is a single force with no net movement. So when the pure rotation happens, right? So when you apply force through the center of resistance, I told you there is a translation. But when you apply a force at any point other than the center of resistance, there is going to be rotation or tipping. So next one we have is the root uprighting. So when the counter movement applied intentionally at the bracket is more than the moment of the force, the root moves in the direction of force, but the crown tips in the opposite direction. So that is root uprighting. So you can see here, this was the original position of the tooth, and this is how it has gained the final position. So when the moment to the force ratio of 13:1 is applied at the bracket, the equivalent force system at the center of resistance is a force to move the tooth plus a small net tendency for the root to tip in the direction of the force. So center rotation, when the moment to force ratio is 13:1, is at the crown of the tooth. That's when only the root is going to move. Now we read about intrusion and extrusion. So intrusion is easy when the tooth is intruded into the socket in the apical direction, intrusive forces, and the extrusion is when the tooth is extruded. So this is going to be a bodily displacement of the tooth along the long axis. Now torque is a kind of reverse tipping. So in torquing, what's happening, there is a lingual movement of the root. If you can see here, so this is the root and it has moved palatally or lingually, and this is the crown here. So root movement is achieved by keeping the crown of the tooth stationary and applying a moment and force to move only the root.